Hey everybody, this is Wakeangel2001, breaking format a little bit. A couple days ago I uploaded my video about the super wolf blood moon, which, was video of a lunar eclipse. And it got me thinking. I did a lunar eclipse, and then last year I did the solar eclipse, and I've also done the Venus and Mercury transits, so I kind of done a lot of stuff that involves one object passing in front of another object in space, haven't I? And it got me to thinking. In recent years, there's been this rather interesting resurgence of people who publicly espouse that the Earth must be flat, and I have gleaned hours upon hours of entertainment laughing at videos debunking flat earthers, or even straight up watching flat Earth videos to laugh at them. But it got me thinking, why? How did this get to become a thing? And I see in flat earthers the exact same thing I saw in the YouTube creationist boom, from way back when YouTube was first a thing. Basically, the people who claim the Earth is flat, they use the same kind of arguments and rhetoric. The whole, all scientists are part of some global conspiracy that's been going on for a long time. All evidence is faked or doctored in some way. It's basically ad hominem attacks against people against scientists and scientific organizations. Arguments from incredulity about these things look this way, so how are they not that way? And what was the third one? I was just thinking about it. No script here. The third one was the conspiracy angle. There must be some reason why people are thinking this. And well, it got me thinking that's not how anything works. You don't get to be right by trying to poke holes in your opponent's theories or what they say. Proving your opponent wrong does not make you right by any stretch of the imagination. It simply doesn't. That's not how it works. Even if you somehow manage to prove your opponent wrong, you still haven't presented any evidence to show that you are right. It could be that some other thing is actually the right thing. That guy says 2 plus 2 equals 3, but we all know that 2 plus 2 equals 5, right, bros? Yeah, we're the fathers! That's just not how anything works. You have to actually show how your thing works. So I figured the best way to come at the flat Earth angle is to actually just, show a model. The thing is, observable fact or not, the round Earth is a model that explains observed phenomenon. So let's do a quick little thought experiment. This is something you can easily confirm with observational data that you wouldn't need any special equipment for, just straight up going out and looking at the moon. So yeah, it would look like something like this.
So here's what I mean by the explanatory power of a model. You start with an observation. In this case, the sun or the moon always appear to be just about the same size no matter what time of day you look at them. Whether they're rising or low on the horizon or at their zenith positions, whether they're above you or low on the horizon, they always look the same size. And this is perfectly explained by the round Earth model. Because you see, the Earth is about 4,000 miles in diameter at the equator. Of course, I personally live in New York, which is roughly halfway between the pole and the equator. That's 42 degrees north latitude. It's close to halfway. So that means that the diameter of the Earth at that point is about 2,000 miles. That means over the course of a day, my distance from the sun or moon changes by about 2,000 miles. So when you put in the distance to the moon, which is about 238,000 miles, that 2,000 miles equates to only about a 0.8% difference. At the equator, where the difference is the biggest it can possibly be, you only get about a 1.6% difference. You'd be really hard-pressed to detect this with the naked eye. You'd have to, like, use a telescope that has a ruler etched into it or something. I'm pretty sure they do have something that can measure the angular diameter or something that you're looking at in the sky. You have to use a tool like that to actually see it, because you're not really going to notice that with the naked eye observation. And the numbers are even bigger for the sun. Yeah, since the sun is 93 million miles away, that 2 to 4,000 mile difference is only 2 to 4 thousandths of a percent. That is so tiny that I don't think you would be able to observe it from the surface, because you would get too much interference from atmospheric fluctuations. You know, like the way everything seems to wobble slightly when there's temperature differences in the air. Like the error bars due to atmospheric distortion would be bigger than the variance. Like, the only way you could observe this is if you were doing so with very sensitive equipment and you had no atmosphere in the way. And to get ahead of you, you gotta use a solar filter when you're taking a picture of the sun, or else you're just gonna get a big nasty glare, and you're not actually gonna be able to see the sides of the sun at all, because you'll just have a big old glare taking up your entire screen. Now again, the reason why I did all that was just to show how a model can actually represent observed data. But according to the flat Earth model, the sun and the moon are supposed to be much smaller local objects that float over the flat disk of the Earth. Now, I'm not even going to get into how this means that it would be impossible for them to ever disappear below the horizon, but even if they didn't, you would notice something extremely different about the way you would see them. When they're far away, just rising or setting, they should appear significantly smaller than when they're overhead, because when they're overhead, they're much closer to you than when they're rising or setting in relation to their size. So this is not observed in reality. So there you go. The model fails to predict an observed fact about reality.
So there you go. So see, if you're a flat earther, then I use that very generously, because I'm pretty sure across the entire planet there's only probably a few thousand people at most that actually do believe the Earth is flat. And even then, I'm still being generous, because some people who espouse a flat Earth belief are probably just contrarians who don't want to go with what the consensus says. And then there's other people who are probably just trolling or having some fun, like saying they believe it. But you know, I'm not going to question it. Even assuming that everybody who says they believe the Earth is flat is 100% sincere, that's still probably only a few thousand individuals around the world at most. Yeah, like, because there's some flat earthers say there are people who believe the Earth is flat all over the globe. So, you know, contradicting yourself in that one sentence or obvious joke. You know, you make your choice. But yeah, like I'm saying, you aren't going to prove anything just by trying to discredit or disprove the idea that the Earth is round. You would need to have a model of a flat Earth that explains all visibly observed phenomenon. And you can't just say, that's faked, that's not real. That doesn't mean anything. You're just making empty assertions at that point. And if you make an assertion, you need to have some evidence to back up your assertion. So, like, pointing at a picture and showing how if you turn up the gamma, then you can see some pixel artifacts suggesting that it's been photoshopped, that doesn't really show that the image has been faked. What it actually shows is that you don't know how JPEG compression works. So yeah, that's kind of important. So you forget about trying to disprove the leading theory. Prove your own theory. That's how science works. And it's the thing that flat earthers, intelligent design proponents, creationists, and basically, homeopathic medicine, anti-vaxxers, you know, like, oh yeah, I'm going all over. essential oils sales reps, you know, all those people that espouse pseudoscience and want to get their turn, like they want to have their like you gotta actually propose it. Show how you are right. You know, that's how science is done. And unless you can do that, then there's really no point in taking you seriously. But seriously, keep up the crazy, stupid videos because, like I said, I get a huge laugh out of those. Alright, so this has been Wakeangel2001 talking about something a little bit more sciencey, but mostly just having fun at the expense of dumb people. We'll see you next time.